So, have you ever planned out a massive project, perfectly scheduled every single step on paper, and then immediately watched it completely fall apart on day one?
Oh, absolutely. Everyone has.
Right, like you print out your beautifully color-coded timeline, you stick it on the wall, and you just think, look at this
It
masterpiece.
feels very reassuring.
It does. But today, for this deep dive, we are going to entirely shatter that illusion of the perfect plan. Because a brilliantly mapped out project is completely useless the second it collides with the messy reality of, limited people, missing equipment, and just ticking clocks.
Yeah, it's a universal experience, really. Whether you're, I don't know, planning a weekend garage clean out or a
Yeah.
multi-million-dollar corporate infrastructure project,
Exactly.
you create this mathematically perfect timeline, and it looks great.
Yeah.
But the core reality we're diving into today is quite blunt.
Hmm.
A project network schedule is not a real schedule until the physical resources have been assigned.
Right.
And a cost estimate is not an actual budget until it has been time-phased.
Okay, I want to dig straight into those, hidden constraints lurking in the shadows of every project. Because before we can fix a broken schedule, we have to understand what actually breaks it, right?
Right. You have to transition from the abstract idea of planning into the physical barriers of reality.
So when we talk about these constraints, what are the actual walls we hit first?
Well, the most obvious wall is people. But it's not just a matter of needing warm bodies to do the work.
Right, because a graphic designer can't pour concrete.
Exactly. Human resources are classified by highly specific skills. You need programmers, you need mechanical engineers, specialized welders.
Yeah.
And a massive blind spot in project planning is assuming people are interchangeable.
Oh, I see that all the time.
You cannot just, swap a marketing director into an inspector's role
Right.
and expect productivity to remain the same.
Interchangeability usually comes with a massive loss of efficiency or just, well, outright failure.
Yeah, and even if you have the perfect engineer or the perfect welder ready to go, what happens if the steel they need to build with is stuck on a cargo ship somewhere?
Oh, man.
Right. That brings us to materials. Material availability can completely dictate the rhythm of an entire project timeline.
Okay, let's unpack this with an example.
So consider the logistics of delivering and constructing an oil rig tower in a Siberian oil field.
Sounds incredibly difficult already.
It is. The environment is so extreme there that they only have a very small one-month window during the summer to actually get the materials on site and set them up.
Wait, what happens if they miss that 1 month window by just, a few days?
Any delivery delay means a one-year wait.
A whole year?
A full year. The winter freezes the routes, shuts everything down, and you're just bleeding capital for 12 months while your multi-million-dollar project sits in the snow.
That is terrifying.
The material schedule dictates everything in that case.
Yeah.
Or, look at the resurfacing of the Golden Gate Bridge.
Oh, yeah, I read about this in the sources.
The material scheduling for that project was dictated by a strictly limited work window to avoid crippling San Francisco traffic. They could only work between midnight and 5 a.m.
Which sounds stressful enough on a standard timeline, but there was a massive financial penalty attached to that, right?
Yes, a brutal penalty of $1,000 per minute for any work taking place after 5 a.m.
$1,000 a minute. See, that is exactly what I mean about reality colliding with a paper schedule. If your materials aren't staged perfectly for a midnight start and your crew is scrambling,
You're losing money immediately.
you are bleeding thousands of dollars before the sun even comes up.
Which naturally leads to the assumption we make about the tools we use to build things, right? Equipment is notoriously overlooked as a constraint.
How so?
Planners often just assume that the heavy machinery they need will be sitting there waiting for them.
Right.
Imagine an organization owns, say, 4 heavy earth-moving tractors.
Okay.
A project manager maps out a job 6 months from now, needs 1 tractor, sees the company owns 4, and assumes it won't be a problem.
But they forget that 3 other project managers across the company are doing that exact same math on their own independent schedules.
Exactly. When that 6-month mark hits, all 4 tractors are suddenly tied up on other sites.
Wow.
The equipment constraint forces you to pool resources across all projects before you even begin, or you just face cascading delay costs.
Okay, so we've got people, materials, and equipment. But there's another hidden barrier here, which is just the physical reality of space, the whole working in tight places concept.
Yes, space is a huge one.
Just because tasks can technically be done at the same time on a piece of paper, the physical environment might completely prevent it.
The physical environment literally forces your hand. Think about renovating a small compartment on a sailboat.
Sure.
In theory, you might have 4 different tasks that could happen independently. You have the plumber, the electrician, the carpenter, but the compartment only physically fits one person at a time safely.
Right, can't stack people.
Suddenly, parallel tasks are forced to become sequential.
I instantly picture, like, cooking a massive Thanksgiving dinner.
Oh, that's a good comparison.
Yeah, like, you might have all the ingredients, you have a perfectly timed recipe, you have 3 family members in the kitchen ready to help cook.
But there's a bottleneck.
Exactly. Your physical constraint is that your oven only fits 1 turkey at a time. The physical space dictates the schedule, no matter what your recipe says or how many cooks you have standing around.
That is the perfect analogy. Or consider a mining shaft where it is only physically safe for 2 miners to work at a particular depth.
Right.
There are also safety constraints, like contracts that prohibit any groundwork from happening within a 2,000-foot radius of a communication tower while it's being constructed. Space is a resource, and you can run out of it.
So when the plan inevitably hits reality and push comes to shove between all these constraints, what do you sacrifice? Because you can't always have everything.
This is the ultimate project management fork in the road. You have to classify the kind of problem you're facing. And most scheduling requires you to define your project as either time-constrained or resource-constrained.
Let's unpack time constraint first. That implies the deadline is king.
The deadline is imposed and completely fixed. If things fall behind, you must add resources to ensure it finishes on time.
Okay.
Time is the critical factor, and resources are flexible, though ideally, you want to use no more than necessary to avoid cost blowouts.
But how do they manage that without just throwing infinite money at the problem and hiring 100 extra people?
They use a strategy called resource smoothing. It's a way to level out the demand for resources so you don't have crazy expensive spikes in hiring or equipment rentals.
How does that work in practice?
You do this by delaying non-critical activities, using what's called their slack.
Slack meaning the wiggle room a task has before it starts delaying the final deadline.
Precisely. Let's look at a botanical garden construction project.
Sure.
At one point on paper, the schedule called for 4 backhoes to be operating at the exact same time on different tasks.
Which means renting 4 expensive backhoes.
Right. But the project manager realized the task of building the perimeter fence and retaining walls had some slack. It could be delayed a few weeks without pushing back the final opening day of the garden.
Oh, I see.
By choosing to delay the fence and walls, they smoothed out the demand. They were able to reduce their peak requirement from 4 backhoes down to just 3 without delaying the project at all.
That's smart. But I have to push back here. What if a client demands both?
Ah, yes.
Like, what if they say to you, look, you only have 3 programmers, there is 0 budget to hire anymore, and this new app feature absolutely must launch by Friday? They refuse to budge on the time, and they refuse to budge on the resources.
This raises an important question, and it's the trap so many managers fall into. It is a mathematical impossibility.
You just can't do it.
You cannot have it both ways. That scenario is the second classification, a resource-constrained project. This assumes the level of available resources cannot be exceeded under any circumstances.
All right.
If you only have 3 programmers, that is a hard concrete wall.
Yeah.
And if those 3 people are inadequate to hit the Friday launch,
The project will be delayed. It has to be. Something has to give.
denying this reality is exactly why projects fail midway through, at a point where corrective action is almost impossible.
Yeah.
The trick in a resource-constrained project is to prioritize and allocate your limited resources to minimize that inevitable delay as much as possible without exceeding your limits.
Okay, but wait. In an era where, AI can generate a movie from a text prompt in 10 seconds, you're telling me a computer can't just mathematically calculate the perfect schedule for a few dozen employees who are stretched thin?
It sounds counterintuitive, I know, but the resource scheduling problem is what mathematicians call a large combinatorial problem.
Combinatorial meaning the number of possible schedules just explodes exponentially as you add variables?
Let's map it out. If you have 5 tasks and 3 people, figuring out the best order is manageable. You could probably do it on a napkin.
Sure.
But if you have 20 tasks, 10 people with different skill sets, and 5 pieces of equipment that can only be in one place at a time,
It's messy.
the number of possible schedules jumps into the millions or even billions.
So even a supercomputer struggles.
Advanced computers try to use things like linear programming, which is essentially an optimization algorithm that tries to crunch thousands of variables to find the single mathematical peak of efficiency.
Right.
But the data requirements and the sheer number of combinations make finding the single optimum schedule virtually impossible in real time. The mountain range of possibilities is just too vast.
If the supercomputers can't give us the perfect mathematical answer, what do we actually do on the ground?
We abandon the idea of perfect math.
Really?
Instead, software relies on heuristics. These are practical rules of thumb. They don't guarantee the absolute optimal schedule, but they consistently yield a good enough schedule that minimizes project delay when you are resource constrained.
So reading through the sources, software uses 3 specific heuristics to make these priority decisions, and they are applied in a strict order. Walk me through the logic here. Why is rule number 1 minimum slack?
Well, when resources are tied up, the task that has the least amount of wiggle room gets the resource first, because it poses the greatest threat to the final deadline.
That makes sense.
If task A has to be done today or the whole project is late, but task B could technically wait a week without pushing the final launch date, task A gets the worker. It protects the critical path of the project.
It makes total sense. But if 2 tasks have the exact same amount of zero slack, we move to rule number 2, smallest duration. Why do we prioritize the quickest task?
Because you want to clear the board. If you have a worker who could either tackle a task that takes 2 hours or a task that takes 2 weeks.
You want them to knock out the 2-hour task first.
Exactly. It gets that activity out of the way, preventing a bottleneck, and frees up that resource to be deployed elsewhere much faster.
And if there is still a tie, rule number 3 is just the lowest activity identification number, like task 14 goes before task 50.
Right. It's just an arbitrary tiebreaker to keep the machine moving forward. You have to keep moving.
Okay, here's where it gets really interesting for me. If resources are so heavily constrained and we are agonizing over who does what, why not just split the difference?
What do you mean?
Why not say, okay, we only have one software engineer. We'll have her work half a day on project A and half a day on project B. Problem solved. We hit both targets.
It sounds incredibly logical on paper. It's a concept called splitting. You interrupt work on one task, send the resource to another, and then bring them back.
Yeah.
But industry veterans emphatically argue to avoid this whenever humanly possible.
Because human brains aren't computers. We can't just, pause a process and instantly boot up another one.
Precisely. When you split a task, you incur hidden startup and shutdown costs. Take the example of a structural bridge designer.
Okay.
If you pull them off one complex bridge designed to work on another halfway across the country, they have to physically and mentally shift conceptual gears.
Right.
They have to put away the plans for Bridge A, pull out Bridge B, remember where they left off, refamiliarize themselves with the local weather variables, the soil composition, the math.
That mental load is exhausting.
It is real, and it is measurable.
Yeah.
Studies show that task switching can cause a 20% to 40% loss in efficiency.
Up to 40% efficiency loss just to context switching. That is wild.
It's a massive drain.
But it makes perfect sense if you think about it, like trying to read 3 different complex mystery novels at the exact same time.
Oh, wow, yeah.
Like every time you switch to a new book, you have to spend 20 minutes just rereading the last chapter to remember who all the characters are, where the clues lead, and who the killer might be. By the time you are back in the flow, it's time to switch books again. You'd never finish any of them.
That is exactly what happens to project resources. And it highlights why managing these schedules isn't just a mathematical problem. It's a deeply human problem. You are managing personalities and cognitive loads.
So how do you manage a room of 20 highly skilled engineers without the whole project grinding to a halt?
Look at how former Google CEO Eric Schmidt approached this. He famously outlined a philosophy for managing technologists, whom he affectionately called geeks.
Okay.
He argued that putting them together in project teams creates highly productive peer pressure. They care a great deal about how their peers perceive their technical work.
They want to impress each other with elegant solutions.
So letting them drive each other through that peer pressure is highly effective. However, Schmidt also warned that too many cooks spoil the broth. If the group gets too large, there is a tendency for what he calls intense technical navel-gazing.
Meaning they get so caught up in the sophisticated details that they lose sight of the actual deadline. They will argue about code architecture for 3 weeks while the launch date just blows past.
Exactly. Yeah. So the rule is to break large projects up so that small teams can be assigned to them. Keep them focused, keep them accountable to each other, but don't let the room get too crowded.
That makes a lot of sense.
And you also have to balance your teams. You pair veterans with new hires, not just to share technical knowledge, but to socialize the newcomers into the actual culture and pacing of the organization.
We've been talking a lot about managing constraints on a single project. But the difficulty of managing resources scales exponentially when an organization is running multiple projects at the same time.
It becomes a multi-project mess. And the most common problem you encounter is the ripple effect. Because projects inevitably share resources, a delay in one project instantly creates a bottleneck in another.
It's like a traffic jam on a highway. One driver tapping their brakes shouldn't be a big deal, but it causes the car behind them to brake and the car behind them until you have a mile-long standstill. Systemic gridlock.
Consider multiple development projects competing for access to one specific equipment testing lab. When Project A runs late, Project B can't get into the lab,
Right.
which means Project B's coders are stalled, which means the next project those coders were supposed to move to is also delayed. Overall schedule slippage becomes systemic.
But there is a way to actually win the multi-project game, and the story of the U.S. Forest Service from the sources is an incredible example of this.
It's a powerful demonstration of why resource scheduling matters. The Forest Service was trying to put together a comprehensive 2-year plan for their operations. They mapped it all out, and management thought it looked totally doable.
On paper.
On paper, yes. But then an engineer pointed out a glaring flaw.
Mm-hmm.
None of the computer printouts had factored in the resource column.
They were just looking at time. They weren't looking at the actual people required to execute the work.
So they reran the modeling with the actual labor skills included. The output was startling. That perfectly doable 2-year plan instantly turned into a 3.5-year plan.
Wow! Just by adding the reality of their human resources.
They realized they had a severe shortage of very specific skills road engineers and environmental impact specialists. But here's the brilliant part. Because they now had this data, they could do the analysis.
Right.
They discovered that by hiring just 3 specific skilled people, they could get the plan back on a 2-year track.
And it gets better because they realized if they hired just a few more specialized folks beyond that, they could compress an extra year's worth of projects into that same 2-year window.
Which would result in an additional $3 million in revenue. The department quickly approved the extra hiring, and they got it done. All because they stopped looking at just time and started mapping out their actual resources.
So what does this all mean when we bring money into the picture? We've covered time, we've covered people, materials, and equipment, which brings us to the final reality check for any project. When things scale up, the ultimate constraint is always money.
We've established that a schedule isn't real until resources are assigned. The final piece of the puzzle is that a cost estimate is not a budget until it is time-phased.
Time-phased budget baseline. It sounds like dense corporate jargon, but the mechanism behind it is absolutely vital. Walk us through a scenario so we can understand exactly how this is calculated. Let's use the $4 million example.
Okay, imagine you are developing a new product. The project is scheduled to take 10 weeks, and the total estimated cost is $4 million. To keep it simple, management just divides that up and assumes a constant burn rate of $400,000 a week.
Okay, 10 weeks, $4 million total. Got it.
Now, management wants a status report at the end of week 5. You check the numbers. The planned costs for the first 5 weeks were $2 million. But the actual costs you've incurred so far are $2.4 million.
So on paper, you look like you are $400,000 over budget. The alarm bells start ringing. The project is bleeding cash.
It would be very easy to conclude there is a massive cost overrun, but do you actually know that? What if that extra $400,000 represents the fact that your team worked incredibly fast, knocked out week 6's tasks early, and the project is actually ahead of schedule?
Oh, wow. So you aren't bleeding money, you're just paying for work sooner than you expected. Like you bought the materials a week early.
Exactly. Now assume another set of data at week 5. Your planned costs were $2 million, but your actual costs are only $1.7 million.
So management throws a party because you're $300,000 under budget.
They might, until they realize that the project is drastically behind schedule, and the only reason you haven't spent the money is that no physical work has actually been accomplished. The materials never arrived, so nobody got paid.
It's basically like checking your checking account in the middle of the month. If the balance is way lower than you expected, you aren't necessarily broke. You might have just decided to pay your rent 3 days early.
Right.
You can't just track the total amount of money. You have to track the exact timing of the work alongside the money.
That is exactly why the industry relies on a time-phased budget baseline, what they call planned value. It ties the physical completion of the work to the dollar amount.
Makes total sense.
If you just take your total budget and divide it evenly across the weeks, You are creating a mathematical fantasy. Without time phasing your budget to match exactly when your resources are scheduled to be working and spending, you have absolutely no reliable way to measure your actual performance or the true health of your project.
You are just flying blind, looking at a bank balance and guessing.
If we connect this to the bigger picture, good scheduling and good cost control are entirely impossible without it.
Let's bring this all together. We started with the illusion of the perfect plan, and I think it's safe to say that illusion has been thoroughly shattered today. We've learned that a project network is just a fantasy until the people, the materials, and the equipment are locked in.
Absolutely.
We've seen the heavy 40% efficiency cost of context switching and why we can't multitask our human brains like computers. And we've unpacked the mechanism of why a budget is completely meaningless unless it's mapped over time to match the actual work.
It requires a fundamental shift in mindset. You have to move from asking the abstract question, when do we want this done,
Yeah.
to the concrete reality of who's actually going to do this and when are they available.
I want to leave you, our listener, with a thought to mull over. We've been talking about this in terms of massive corporate projects, systemic gridlock, and Siberian oil rigs. But try applying this to your personal life. Think about your own personal goals, or maybe those New Year's resolutions that tend to fall apart by February. Have they been failing because you've been treating them as time-constrained projects?
Oh, that's interesting.
Like you just set an arbitrary deadline, I will learn to speak conversational Spanish by June, when in reality, your personal energy, your attention span, and your free time are strictly resource constrained.
Usually they are.
The next time you plan a major personal project, don't just schedule the deadline. Schedule the exact hours of your own human resources. Because as we've learned today, your plan isn't real until you do. Otherwise, you're just staring at a beautiful, mathematically perfect X-ray of a broken system.